You have already learned to restrict the domain of a rational function by excluding any real numbers that make the denominator equal to 0. In this example, setting the denominator 1 minus 3x equal to 0 results in x equal to 1/3. Therefore, the domain is the set of real numbers excluding the number 1/3, written as x such that x is not equal to 1/3. The vertical asymptote is therefore x equals 1/3. Remember that an asymptote is an equation. In order to find restrictions on the range, you need to examine the number or numbers that the function tends to, as the x values tend to plus or minus infinity. By trial and error, select large values of x and observe the value the function approaches. For example, if x equals 200, then y is approximately -2/3. For an algebraic solution, you solve the given function for x and eliminate any y values that make the denominator equal to 0. So, multiply the given equation by 1 minus 3x. Y multiplied by 1 minus 3x equals 2x minus 1. Simplify, giving y minus 3xy equals 2x minus 1. Bring all terms in x to one side of the equation, giving -3xy minus 2x equals -1 minus y. Factor out x, giving x multiplied by 3y plus 2 equals 1 plus y. Then, finally solve for x by dividing both sides of the equation by 3y plus 2, giving x equals 1 plus y divided by 3y plus 2. Now, setting the denominator equal to 0 and solving for y, 3y plus 2 equals 0 implies y equals -2/3. Therefore, the range is the set of real numbers excluding the number -2/3. Remember that this is the approximate value you obtained using trial and error earlier. The horizontal asymptote is therefore y equals -2/3. Remember again that an asymptote is an equation. The graph confirms the solutions obtained algebraically.